meeting is being recorded.
So good afternoon, everyone. Today is January 13th on Friday, and we're here with Daryl Oster and the ARC team to discuss the evacuated tube transportation system and what we can do with it and how we can use it to lower the cost and improve the quality of life for everyone. So with that introduction, would you like to go ahead and take the floor, Daryl?
Yeah, sure. Thank you, Robert. And it's great to meet everybody online. I will go into the screen share mode here. I'm not real good at Zoom. I haven't done it a lot, but hopefully if there's any issues, Robert or one of you can call my attention to it, and I will try to so I'll close that out here. And it is everybody seeing the first slide up here? I'm going to go ahead and start the slideshow.
Yes.
Oh, okay.
Yes.
Okay, good.
Yeah, and you can act like nobody's ever heard of ET3, or and that it's just a general audience, and then we can go into more technical stuff when those questions come up.
Okay. Right here on the screen, if you can see where the mouse is, this is in 1956, kind of the start of computer storage revolution. This is a 5 megabyte hard drive that weighs 1 ton being loaded onto a 707 in the year 1956. And right here in, this was in 2016, they came up with a 200 gigabyte micro SD card, the size of a person's fingernail, and that weighs a half a gram. So that's 80 billion times more data density in 60 years. The question that we're posing is, can mobility be improved like this? And we believe that it can. Dr. Tom Fry is an expert in the future. And he shows that transportation is an exponential growth curve, just like computers, just like Moore's law, but it is a more gradual growth curve. And he has shown that the average speed of transportation is growing exponentially, and ET3 really is the next quantum leap in transportation. We moved from muscle power. Muscle power was a huge improvement for transportation for humans, allowing a doubling of the standard of living because people could use a much less amount of time to survive. And then the switch to steam power, the switch to petroleum power, and with ET3 and electrification and electric power, we can have a much vastly improved standard of living. Dr. Fry says that driverless technology will be the most disruptive technology in all history, and we're on the verge of it happening. In a few states, automated transportation is legal and occurring. City governments were going to have to rethink a lot of cities. A lot of the land that is devoted to parking and stuff. That there will be real disruptions. About half of the revenue stream for cities is traffic violations, and 40% of sales tax comes from automobile sales. So there's going to be some major disruptions in our existing systems because of the automation and transportation that's taking place. Infrastructure projects represent a huge opportunity to connect the world. And Dr. Fry has as one of the leading futurists in the world, has identified these major projects. Connecting the Bering Strait in Alaska is particularly relevant to what Robert is trying to achieve. And There are many other projects around the world in that category of mega projects. Dr. Fry has also recognized that tube transportation is the top global mega project to connect the world. And ET3 now has some competition with the various Hyperloop projects that are going on. The vision of ET3 is basically car-sized vehicles that are magnetically levitated, and they operate in a network of tubes, sending packets of information through the internet, and it can be routed anywhere in a global network is the global vision. We currently ship more goods through pipelines than all other forms of ground transportation combined. More ton miles of transportation takes place. So why not people and freight? ET3 is really the most proven form of transportation in the universe. All of us have been traveling in orbit around the sun on spaceship Earth for our entire lives. Earth is orbiting the sun at over 200,000 miles an hour. And the average person travels billions of miles through the evacuated environment of space in a typical lifetime. So we're just bringing this down to Earth so that everybody can enjoy it, both for transportation and to move cargo, a pallet or two at a time, up to 3 pallets at a time. A major difference from ET3 versus trains is ET3 uses a car interchange philosophy instead of a train switching philosophy to route the vehicles. So the routing and the switching, it is not an issue like it was with trains where the speed is limited and the frequency of vehicles is limited. With ET3, the capacity it is not limited by the frequency of the switching. It's more like a freeway philosophy. So with that, we can achieve much higher capacities. At 400 miles an hour, a 2-tube ET3 system, 1 tube for each direction, has the capacity of 20 lanes of freeway traffic in each direction, a 40-lane freeway. And if we double the speed, we double the capacity. So at 10 times the speed, at 4,000 miles an hour, it would be like a 400 lanes of capacity going across the Bering Strait, the green route here connecting the entire world. That pair of tubes, 5-foot diameter tubes going across the Bering Strait, could carry 5 times more traffic. If each capsule had 1 pallet of goods on it, it could carry 5 times more cargo than all of the container ships traveling between China and the United States. It has that much capacity. So you can see that ET3 really is has the capacity and the capabilities to do what has happened in computers and in telecommunications. What's the cost of this, though? That's the big question, and how sustainable is it? For an environmental standpoint, ET3 offers 50 times more passenger miles of transportation or ton miles of transportation per kilowatt hour compared to the most efficient car or electric train, and uses much less land, much less materials, and much less labor to build it. It's really a 10x and more paradigm shift in transportation. ET3 improves the economics of transportation, the value of transportation. The proven way to attract investment is to improve value. Each job created to prop up passenger trains absorbs the entire tax output from 5 to 10 average Americans. It's not sustainable. Trains have been outmoded by cars and jets 100 years ago. Humans are the only species to nurse the old at the expense of the young. And that is what's happening in our government today, sadly. is that the dinosaurs are being subsidized and the newborns are forgotten. With ET3, you can see the vast difference in the amount of concrete and steel for this bridge span. 35 tons of material per meter. With ET3, 1 ton of material per meter of span to make the two tubes. So vastly more efficient from a material standpoint. From a tunneling standpoint, 1/18 of the amount of rock to blast out of the way when you want to put the two tubes underground for the very high speeds that's necessary. ET3 has attracted some competition. You've probably heard of Elon Musk's Hyperloop. He came up with that a couple weeks after we asked him to join the ET3 consortium. And Hyperloop is more designed to accommodate cars, whereas ET3 challenges cars, threatens to replace cars. So with Hyperloop, you could drive a Tesla into a container-sized vehicle and be carried 300 or 400 miles until the batteries run out. And you can see the cross-sectional area of this right here of the high-speed rail. It is a huge amount of earthwork and a huge amount of expense for that infrastructure. Hyperloop's better than that. It's maybe half the cost of trains, high-speed rail. Depending on what version you go with, it might be a fifth of the cost. ET3 is less than a tenth of the cost, probably about a 20th of the cost of high-speed rail. This is some comparisons between ET3 and Hyperloop. The empty vehicle weight of ET3 is only 400 pounds of material for the same car-sized vehicle that we are used to using. Hyperloop, a bus-sized vehicle that can accommodate 30 or 40 passengers at a time, would cost maybe 10 times more to build than ET3. You can see the battery weight for the ET3 capsule, 6 pounds of battery, 8,900 pounds for the Hyperloop vehicle, which limits the travel range to 400 or 500 miles. The payload difference, this is one area where ET3 doesn't have as much payload capacity as Hyperloop, only 800 pounds per capsule, or 900 pounds of cargo if there's no life support, but 800 pounds of passengers, 4 to 6 seats of capacity. The cost per vehicle is about $48,000 for ET3. The cost per seat, about $8,000 cost per seat versus about $40,000 cost per seat for Hyperloop. Train cost now is maybe $80,000 to $100,000 per cost for high-speed rail, and that's per seat of capacity, $80,000 to $100,000 per seat. The maximum speed capacity of ET3, 4,000 miles an hour, 6,500 kilometers per hour. For Hyperloop, 760 miles an hour. The capacity, 120 passengers per second. So the infrastructure costs a lot less, but the capacity is much higher. Security and safety with ET3, it's impossible for a terrorist to target a single person in a single vehicle as it is with a car driving down a freeway. But terrorism and that type of thing, fortunately, constitutes less than 0.1% of transportation-related fatalities. So with ET3, we focus on what it is killing 90% of people, which is failure to control the right-of-way or failure to control the conditions of travel. We have weather issues with cars on the road and airplanes in the sky. We have operator error with automation and isolation from those chaotic conditions and much better control of the vehicle with much better controlled conditions. ET3 promises orders of magnitude improvement in safety compared to our existing transportation modes. food and water security. Cargo could go anywhere in the world in this network, a pallet at a time, minimum shipping quantity instead of a container at a time. Security and safety issues. You don't have a lot of these problems with ET3 that you do with typical transportation modes. The first project for ET3, we're proposing a demonstration project that will cost about $30 million for 3 miles of one tube and one capsule. The plan is we need 3 miles for a 400-mile-an-hour demonstration. Preferably, it would be close to a large city, major population of over 2 or 3 million people, and be close to the outskirts of the city or in between two cities that are more than 1 million. So we could extend that out later. So if it's a location with more than 60,000 cars a day, 100,000 passengers per day, projections for our demo operates as a major amusement attraction ride. It can recover its cost in a couple hours, or excuse me, a couple years of operation. As far as the ET3 team goes, this is my mentor. I don't know if anybody recognizes him. His name is Frank Davidson. He's the one that built the tunnel under the English Channel. And he's before he died, was one of our biggest supporters. I don't know if anybody recognizes Jock Fresco and Roxanne Meadows. This is at the Venus Project in Florida. And our team in China that has built prototypes and had been operating in 2008, long before Elon Musk ever mentioned the words Hyperloop. So it is a world-class team that have come together and have done the heavy lifting to develop this technology. And it literally is shovel ready, waiting for right away to build it on. So that's the basic presentation. Any questions? I can go back on slides at this point.
All right, Daryl, that was a lot of great information. Thank you very much. I want to be clear, this is all, it's been in the works for many, many years to do something. New opportunities this year means we're exploring new opportunities, and this is kind of starting over. So we haven't engaged any governments yet, or haven't engaged any city councils or boroughs or anybody. This is the first introduction to this technology. Where we go from here will be pretty exciting. So I'm going to go and do a round robin to make sure everybody gets a chance to be heard. If you don't have anything to say, just say pass. If you have something, please try to keep it to a minute. If we're feeling chatty, then we can go into a second round robin of questions. So let's see here. So start ladies first. Current, would you like to ask question, make comment?
Yes, yeah, that was fascinating. Thank you. One question is, do you have cities in mind, or an ideal city or go-between for demonstrating this? I know you mentioned some parameters that would be beneficial. What would your ideal city be, or area?
Yeah, that is a really great question, and we have several city pairs that we have identified in the United States as being an ideal first demonstration. We think the project that we call the Texas T-bone is probably the lowest hanging fruit that would if I could is everybody seeing my desktop
Yeah,
here?
Yeah, you're still in control of the screen.
Oh, okay, great. Let me get to the, okay. So here we go. The United States, let me zoom out a little bit to show the perspective of this.
Okay, so I also want to be very clear with everyone. What you're seeing are suggestions, options, explorations. There's been no consideration, no discussion, no plans laid. So I just don't want to have anybody have any false expectations about where this is at, where these lines may or may not go. These are all just discussions and exploration for future discussions.
Okay, I'm not real sure what's going on here, why it's, let me zoom in on this one. It might work a little smoother. Okay, so here we have Dallas Fort Worth. This is proposed routing for ET3 that would connect the most population with the fewest miles. And San Antonio over 1 million, Austin over 1 million, Dallas Fort Worth 4 or 5 million, Houston 5 or 6 million. So this connects several million people and goes through several other major cities. Also connects College Station, University there, and we see that as probably the lowest hanging fruit. It is connecting Dallas and Fort Worth. Downtown areas would be a good start. Connecting Austin and San Antonio. All of those are good routes. I'm zooming out a little bit here. Florida has many good routes also to connect. We were one of 20 proposers that qualified to propose a technology for the Florida high-speed rail that was a constitutional amendment more than a decade ago. And Tampa to Orlando route was about 100 miles, and that's a real good route. But ET3 could have connected the major population centers of Florida with another T here that would also connect up to Atlanta. So that there are many many good ideal locations. California has a lot of low-hanging fruit as well. LA to the Bay Area, down the Central Valley of California is a good route. We also have been talking, I'm not sure how much of this you want to talk about, Robert, but with Alaska, we're talking over $1 trillion worth of oil resources in this area, oil and gas, and ET3 can move oil and gas through capsules that are isolated from the environment and much safer. Three are 4 levels of containment versus only a single level of containment with the pipeline that goes from Prudhoe Bay down to Valdez via Fairbanks. And these are different alternatives for routes to access the oil field. This particular route here is 1,032 miles that would be capable of transporting oil, but also people and goods. Cargo up to 800 or 900 pounds of cargo per capsule. So people tell me that if they ask what time it is, I tell them how to make a watch. So just stop me and jump in if I get too verbose with my answers. And I hope that satisfies your question with a couple city pairs.
Yes, thank you so much. That was great.
I think everybody's muted, maybe except for Can you hear us, Robert? Are you there?
Can you hear me? I can hear you.
Yeah, I can hear you fine, but I can't hear anybody else. I don't know if anybody else can hear us or not. Thumbs up if you can. Okay. So Eric can hear. I can't hear Eric though. Is Robert still there? I can't see what that says. It's not quite in front of your camera.
Okay, I can hear everybody, and now my video's on. I'm
Oh,
just trying
okay.
to get off of saving bandwidth. So I was trying to check in with Dan and see if any questions, but so we'll try this again.
Sure. Yeah, I can hear you guys. This is Dan Bross up in Fairbanks. I'm a news reporter with Public Radio. Daryl, can you talk about the power consumption, how these would be powered and where that comes from?
Yeah, sure. ET3 is electrically powered, and of course, the best source of electric power is probably hydroelectric. It was the first source and continues to be the best. ET3 takes less than a 50th of the energy per passenger mile that electric trains do on a passenger mile basis or a ton mile basis, and less than a 50th of the amount of electric car. So as far as power goes, to accelerate up to 4,000 miles an hour would take over a megawatt of power. About 250 kilowatt hours of electrical energy would need to be added to a 1,200 pound gross weight capsule to accelerate it up to 4,000 miles an hour. But to get up to 400 miles an hour is vastly less, less than a hundredth of the amount of electrical energy. So maybe to 400 miles an hour would take about 2.5 kilowatt hours of electrical energy. And then the vehicle coasts using almost no additional energy. There's a little bit of energy necessary to supply the breathable air for the passengers and to remove the carbon dioxide that's exhaled. And that takes a relatively small amount of electrical energy. When you get to the destination, about 90% of the electrical energy that was used to accelerate the vehicle can be recovered with regenerative braking when the vehicle slows back down. Much like when you step on the brakes on your Toyota Prius, it recovers the acceleration energy and puts it back into the battery to be used for subsequent acceleration. And that's why hybrid cars get so much better fuel efficiency than regular ICE engines, ICE powered vehicles, internal combustion powered cars. So I hope that answers your question. I can get more into specifics, and I do have a, let me just pull up a chart real quick here because it will graphically show what I'm talking about. This is for different design speeds in miles per hour. And let's get up here to more reasonable speeds. So if we're talking about this at 187 miles an hour. It takes about 8 seconds at 1G of acceleration to accelerate up to that speed. Then the vehicle would merge into the flow of traffic. This is the curvature, the minimum curvature for 1G of lateral acceleration. This is the kinetic energy involved. That's only a half a kilowatt hour per capsule load of up to 6 passengers to accelerate up to a little bit under 200 miles. At 218 miles an hour, it's about 7/10. So when we get up here in the higher speeds at say 4,000 miles an hour, we're let's see. Oh, here's miles per hour right here, 4,000 miles an hour. We're talking in the orbital stuff here, but let's see, 249 kilowatt hours of electrical energy per capsule. And you get about 90% of that back when the vehicle slows back down. If we use superconductors, we get about 99% of that energy back.
Okay, that really get into the weeds there. I appreciate it. So let's see how our connections are. Eric, can you hear us? Do you have a comment, a quick point or question? All right, still having audio issues.
Open up a chat window and type it in.
Yeah. If you guys can't do audio, you can type it in the chat, and then I'll try to read it so we can get it recorded here. So let's see here. Michael, can you hear us? Can you speak? Do you want to?
Okay, I can read the yes down here. See my question above. Okay, let me
do that here.
See the question above. Are there any windows in this thing? Okay, are they flashing by? That's a great question, Michael. The visibility through with ET3 will be unparalleled. It will be a virtual window that could literally, if you're wearing a virtual reality headset, you could get real-time images from 360-degree cameras that are on pillars above the tube. So it would look like you're flying along at treetop level with virtually transparent vehicle by yourself, if that's what you wanted to see. Or you could have your choice of whatever visual input that you want.
So like a zip line experience that's more comfortable? Is that what a virtual zip line experience that would be more comfortable? Is that it?
Yeah, I hope that answers your question. But beyond that, it could even offer, if you're going through at nighttime, you could see what it would look like going through that same area at daytime. Or if you're bored going across the desert landscape, you could zoom ahead or you could freeze frame if you wanted to count the cattle in a particular pasture as you're zooming by. So lots of visual choices for visual input as you're transporting.
Okay, Janice, I see you have your hand up.
Yeah, hi. So what I'm hearing as to the price doesn't sound like it'll be cost effective for Alaska until it's been developed and used widely throughout the nation in bigger population centers.
Well, that's a great question for Alaska in particular, because you're absolutely correct that it does not make sense to connect, for instance, Anchorage to Fairbanks just from a passenger standpoint. Probably enough. It would be maybe a little bit more expensive than traveling by air if the passenger travel were to pay for it on that route. But if we add in the oil resources, if we extend the line up to the North Slope, and we're talking about the a sustainable oil development where the oil would be used not for burning in cars, but to make high-tech building materials out of, and carbon fiber and high-tech plastics and lasting stuff to make ET3 capsules out, and sections of tube and things like that. Those oil resources, the approximately hundreds of billions of dollars or trillions of dollars worth of oil resources at today's price at $100 a barrel. There's just in one small area up there, there's like 10 billion barrels of oil in the ground. So that's like about $1 trillion of oil. If only $1 a barrel were used to pay for the ET3 system for all of Alaska, everybody in Alaska would essentially have free transportation of cargo and goods. And the oil companies would have cheaper transportation at maybe a half of the cost of moving it through a pipeline or tankers. I hope that answers your question, Janice.
Yes, thank you.
Yeah, so Eric asked questions about hackability and software.
Definitely won't be connected to the internet.
Okay. So what happens in the case of emergency? You mentioned that part of the energy goes to maintain the life support systems for this capsule. So what happens if an earthquake happens and a part of the line takes out? Do people just go flying out into space? How does that work?
Yeah, that's what would happen. So
careful there, people will believe you.
Yeah, a few capsules for a few capsules that would happen. But if we do a side-by-side comparison of the safety worst case scenario that you're talking about, say a meteor impact that takes out a section of tube, and the tube happens to be built right beside a high-speed train. So if the ET3 system and the high-speed train were operating at exactly the maximum capacity of the train, just to keep it fair and compare apples to apples, the same number of people in ET3 capsules would be spread out over 35 times more distance. So if that meteorite were to hit the entire train full of a couple thousand people, in ET3, maybe 100 of those people would be at risk of death versus a couple thousand in a worst case scenario of a train derailment or a complete tube breach like you're talking about. And ET3 won't be immune from risk, but it will be vastly safer than our existing modes. If there were a tube breach, the sensors sense that immediately, and they flood the entire branch of that tube that cannot be isolated from the rest of the network, flood it with air, where the air is emitted through apertures that are sized and spaced such that the air rushing in aerodynamically slows the capsules down at a maximum survivable rate of maybe 2 or 3 Gs, with airbags inside the vehicle that will protect people and protect people from collision. That air in between all of the capsules then will act as a giant airbag several hundred feet long between each capsule to absorb the any collision energy. The vehicles will slowly or quickly slow down and then slowly migrate to the low places in the system on the magnetic levitation. And it might take a few hours to rescue people out of there, but compared to the wings falling off of an airplane cruising at 30 or 40,000 feet, much less risk. And if we put that into context, acts of God do result in some transportation related fatalities, probably less than 1 or 2%. Okay. we prefer to focus on what's killing 99% of the people, and also make the other things safer with ET3 as well.
Okay, so as you're probably well aware, there's some conflict going on over in Ukraine, and there's a part of the line that goes across into Siberia. So can you speak briefly? Well, I guess that's a question on its own. Can you speak briefly to some of the impacts that might have, and where that could go?
Yeah. So what we're talking about on a global basis, for some reason it's not showing up on there. I'll show it on this flat map, but we believe that the benefits to Russia will far outweigh the current risks, and might offer a way to heal a lot that's been happening in the the current times right now. My forefathers were on my dad's side, were from the Odessa area. So they were German immigrants to Ukraine before they came here to the United States.
So, okay, so in regards to economics, what you told me one time, what's the comparison between constructing a 300-mile highway or a length of highway compared to a length of ET3 route?
Compared to the typical 4-lane freeway, ET3 is about a fourth of the cost per mile, and at a design speed of 400 miles an hour would have more than 10 times the capacity, like 20 lanes of traffic in each direction.
So people could basically go to sleep in Fairbanks and then hitch a ride and go to Anchorage for shopping, or go to Barrow for shopping, or any kind of stuff like that. And then I guess another question is that you had mentioned
what is that, about 300 miles, it would take less than an hour. So maybe a time to take a quick nap, but
so the other question that I had pertaining to that was, we are looking at maybe upgrading our intertie so we can move electricity from power stations up north to power stations down south. Could this serve that purpose along with all the other stuff it's doing as part of the economic formula?
Yeah, absolutely. That's a great question. If we look over here at the global backbone in green here, at 4,000 miles an hour, that could carry 120 capsules per second. Each capsule is 250 kilowatt hours of electrical energy. So about $25 at retail cost of 10 cents a kilowatt hour. About $25 worth of electrical energy is also transported by each and every capsule on that global backbone. So at 120 capsules per second, each one with 250 kilowatt hours, that's what, about say 30 megawatts, 30 megawatt hours per second. That's quite a bit of juice.
Okay, we won't hold you to that, but so Janice, I see your hand still up. Did you have another question?
Oh, no, I didn't. Sorry about that.
That's not a problem. So what do these terminals look like? Do you have any pictures of those that you could show us, or what does the interaction look like? How do people move from one tube to another?
Oh yeah, does everybody want to watch a little video?
Well, we have about 10 minutes left, so if you can squeeze it into that timeline, sure.
Yep. Yeah, let me find it here.
And then I'll we can go around and see if anybody has any closing questions or comments. And then, like I said, this is being recorded, so we'll talk about how it gets out. This is a fascinating conversation. It has huge implications, and I think that we need to carefully consider those implications, because the last thing we want to do is to give people false hope. But one of the things that inspires me about this is that and correct me if I'm wrong here, Daryl, but you mentioned something to the effect that this could lower the cost of material goods and transportation to the point where we could sustain what we have now on a 40-hour work week on a 20-hour work week. So those kind of impacts to quality of life and cost of living are part of my motivation for planting the seeds and getting this conversation started while we have the opportunity. Does that flow with your thinking?
Yeah, very good.
The future of transport luckily looks very different than today. Implementation of new technologies no longer require the fast burning of fossil fuel to get you to your desired destinations. With future transport, you can get there a lot faster and cheaper. Imagine a world without pollution and noise from traffic. This world is brought to you by the fifth mode of transport called Evacuated Tube Travel Technology, or ET3 in short. ET3 is poised to reach speeds of, yes, 6,500 kilometers per hour. In the coming decades, an access portal will be built near to you and connect you with shopping malls, supermarkets, towns, beaches, and tourist destinations all over the planet in one go. No more transfers. On the left, you see the tubes with uninterrupted traffic flowing at the design speed continuously and without fossil fuel. This is the ET3 frictionless limousine that floats on magnetic levitation. Magnetic levitation, or maglev in short, truly is the technology of the future and has already been used for decades effectively and safe. Entering the evacuated tube system that allows for frictionless travel happens through an airlock.
I am expert in these basic fields to evacuated tube transport technology for already 40 years. It is feasible technology. It is possible to do. The only thing that is required is that some decision makers will say, yes, we believe in this technology, let's do it. Let's dare, let's take a chance, and let's do it.
This then turns into the world's largest infrastructure project, feasibly a 50-year build out, maybe even longer, employing hundreds of millions of people. I feel that this becomes a fundamental piece of our future.
All right, that's great here. So we are, Robert, towards the top of the hour. So I got two more quick questions, and then we can do a round robin to see if anybody else has any closing comments. But so I just did a quick search, and it looks like the 2023 military budget for the U.S. is about $1 trillion. So if we were to reallocate that budget to an ET3 rollout, how long do you think this system would take to pay for itself?
Well, we think that it's much more powerful to build bridges than walls, and I like that plan. Versus roads, ET3 is far less costly. It reduces the cost of transportation, increases the value of transportation by more than an order of magnitude. So, and the the economic effects of that, the trickle down effects of that, if you think that the automation of communications with our cell phones is the biggest growth market in the world right now, the value of Apple is $2 trillion now. What do people pay for a cell phone compared to what do people pay for a car? So we're looking at a market that is literally 10 times or maybe 100 times bigger than the automation of telecommunications. Does that answer your question?
Well, that sounds promising. Uh, so, so the other question is now, first of all, that this is going to be depending on how it rolls out. Obviously, even if we got unlimited funding and complete support today, it's going to take time. And so, how is this going to impact the stock market and the other existing transportation market and stuff? And then, so this morning I was discussing with a group the state's economic plan and the 5 points of it and how we might be able to flip it on its head, because the first one is to keep the oil companies happy, and then the last one is to build a regenerative economy. And I suggested that since we're promoting a regenerative circular economy, that what we should be looking at is how do we build a regenerative economy that keeps and makes the oil company happy. This type of project could do that because everybody walks away with more money, more influence, and a more secure world all around. So my question is, if let's say that 2023 was the year of ET3. When do you think that we would be taking our first? And let's just say that by some magic we were able to build a line from Fairbanks to Anchorage. And when do you think, or from I like that line from up to the North Slope and over to Barrow or UT Avik. When do you think we might be able to see take the first ride? And then how long do you think, again, optimal conditions, do you think it would take to build out a global transportation network?
Yeah, well, to build out a global network, if we start with that in mind as the global vision, to displace, say, half of global transportation, which is over $10 trillion a year, would take about $10 trillion worth of investment. So 50% of that 5 trillion a year, it takes a couple years to pay for it. And it's going to take, more than 2 years to build it. Maybe 10 years if there's a global effort and if the resources are really put to it. That could be done. Realistically, it might take a couple years to build the first one. We have a 24-month process. It could be built much quicker. It could be built in 6 months if it were like a Manhattan project type of undertaking. Where there's a lot more resources thrown at it. It could be developed much quicker, but we think realistically it'll take us about 2 years to build our 3-mile demonstration, and to demonstrate it at those design speeds, to connect the oil fields and to partner with the oil companies. We believe that it adds a tremendous amount of value to that particular industry to move the oil far cheaper and more effectively than in a pipeline, especially in a cold environment. The pipeline is, as the initial oil field up there has diminished in production, to keep that pipeline full and flowing in the wintertime becomes a greater and greater challenge. So by opening up more fields up there and taking that pipeline apart and reusing that all that steel, the ET3 will take a lot less materials than the existing pipeline because it uses more durable materials and less costly materials.
Okay.
We could probably move 2 or 3 times as much oil through that. If the oil companies could agree to bury the hatchet with the environmentalists, and the environmentalists could agree to do the same thing, and agree that all of the oil taken out of there would be used for lasting purposes instead of to burn up as motor fuels. With that kind of agreement to start with, we think that the oil companies would benefit from manufacturing that into high-tech plastics that might be worth $300 or $400 per barrel instead of $100 a barrel, and keep more of that asset in the ground for a longer period of time to continue to create the same level of profits for their shareholders for maybe a 5 or 10 time longer time frame than just going for the lowest hanging fruit and turning it into motor fuels with a little bit of refinement instead of a lot of refinement to turn it into high-tech building products that offer shipping, or I mean, a building panel that could be used with automated building systems that would offer a R100 wall and be built out of lasting plastics, high-tech materials that cost less than our existing buildings and put a lot more profits into the shareholders of those oil companies.
Yeah. Daryl, it's hard to stop you because you keep saying so much good stuff, but we are at the top of the hour. So I do a quick round robin and see if anybody has any burning questions. I know this is an ongoing conversation. And again, right now, this is just a conversation. We're just planting some seeds for further conversations. Nothing's been decided. So I don't want to give anybody any false hope, but there's a lot of potential here. And the collaborative model is if we can find a way to work together and invest the existing profits we have into this future and then into aerospace and geotourism and data collection, we can move forward together and everybody creates, and then the people in the jobs that are now we have now in these sunsetting industries can either retire well or be trained into these new careers. So anyway, I go through real quick and see if anybody has any burning questions, and I'll start with you, Janice.
I don't have anything. Thank you.
Okay, good. Thank you very much. Thanks for coming. Dan, do you have any questions? Final thoughts?
No, thank you. It was really interesting.
Okay, appreciate it. Thank you very much for coming. Eric, do you are you having any luck? Doesn't seem like you're having any luck with audio there. So, okay, well, I appreciate you coming. So, Michael, any final thoughts or questions you'd like to share?
Questions, security and hackability. I'm seeing some questions here. Nothing for now.
All right. Okay. So
I
Current.
think we answered all those questions that I see in the chat off to the side
Okay.
here.
Okay, Current, would you like to take us
Nice
home?
to meet you all, and I hope you send your contact information through Robert, and we can add each other to our LinkedIn networks and so forth. So
okay. Current, do you have anything you'd like to add on our way out the door?
I do, but I think it would be a whole new topic. So maybe we'll reach out and discuss. I'm curious about the partnership with oil and how the strategic partnership. Yeah, so we can talk about that another time. But thank you so much.
All right. Well,
I'll
thank
just
you very
much. My phone number here. My phone number is 352-257-1310, and I'll repeat it now that everybody has their pens and pencils or typewriters. 352-257-1310.
All right. Thank you, everybody, for taking the time, and for everybody who watches this later. Look forward to the conversations. Have a beautiful day.
Thank you.